Hello students, the topics for today's discussion are electric field intensity and electric line of force. So let us start from the very first topic, electric field. How can we define what is an electric field? The environment created by an electric charge in the space around it such that if any other electric charge is present in this space, it will come to know of its presence and exert a force on it. Or, in other words, we can say that an electric field surrounds an electric charge and exerts a force on other charge in the field, may be attractive, may be repulsive. Electric fields are created by electric charge or by magnetic fields. Electric fields are important in many areas of physics. The next topic for today's discussion is electric field intensity. In the electric field, the electrostatic force on a unit test charge is known as electric field intensity at that point. Or we can say that the electric field intensity is the measure of the strength of an electric field at any point. It is equal to the force per unit charge experienced by a test charge placed at that point. Let us consider a force capital F is exerted on a charge Q. Then electric field intensity at that point will be given by E is equals to F upon Q. The charge is so small that it cannot produce any change in the given electric field. The unit for intensity is Newton per Coulomb. Now let us derive the expression for the same. The electric field intensity due to point charge. Let us consider a point charge Q naught is placed at a point O and a test charge Q is placed at a point P. Both the charges are separated at a distance small r. Now, the Coulomb force on the charge Q by Q naught will be given by 1 upon 4 pi epsilon naught Q naught upon r cube unit vector r. Now, electric field intensity at P will be given by E is equals to F upon Q. Therefore, the expression will become 1 upon 4 pi epsilon naught Q naught upon r cube vector r. Now, the third topic for today's discussion is electric line of force. Electric line of force are simply the reason behind the existence of electric field surrounding any charge. Or we can say that a line of force in Faraday's extended sense is synonymous with a Maxwell's line of induction. They have some particular properties which are as follows. Number 1, they start from positive charge and ends at negative charge. Number 2, the electric line of forces are imaginary, but the electric field they create is real. Number 3, the tangent drawn at any point on the line of force gives the direction of force acting on a positive charge at that point. In SI system, the number of electric line originating or terminating on charge is given by Q upon epsilon naught, which shows that lines associated with unit charge are 1 upon epsilon. Number 5, two line of force never crosses each other because if they do so, then at that point the intensity will have two directions, which is just an absurd. Number 6. Electric line of force can never be a closed loop since they do not start and end at the same point. The lines are discontinuous, start from positive and terminate at negative. 7. The electric line of force do not pass through a conductor as electric field inside a conductor is 0. 8. The electric line of force have tendency to contact longitudinally like a stretched string, producing the attraction between the opposite charges and edge effect. Number 9. Electric line of force starts and ends normal to the surface of conductor. Number 10. The crowded lines represent strong field while distant line represents weak field. Equidistant parallel lines represent uniform field. Non-straight or non-parallel represents non-uniform field. In the following diagram, A is uniform while B, C and D are non-uniform field. From the diagram A, we can see that a single isolated charge acts as a source of an electric field in figure A or as a sink for electric field in figure B. The field of two charges has a complicated shape. Each charge disturbs the field of the other. The opposite charge attracts reflected by the field lines which link together, as in figure C. The like charge repels and no field lines connect them, as shown in figure D. Hope you will understand the topic. Thank you.